Right now, I'm going to start discussing this one by one. Mainly, we will discuss today the RAM and ROM and CPU part. Because in the fundamental lesson, we have not discussed, like actually we discuss only the basics. What is RAM? RAM is random access memory. What is ROM? ROM is read-only memory. We just discussed the basics, but in this lesson, we will go to more depth and discuss further about these components. And okay, so this random access memory or the RAM. So this note is not the same, right? This note is not the same as what we have given in the primary, the first lesson. This has some modifications, right? Okay, so random access memory. Random access memory. What is random access? Random access means, okay, so can you remember cassette piece, cassette tapes? How many of you have seen or listened to the cassette tapes? Maybe in your childhood, cassette piece. Anyone of you? Okay, it seems no one. Great, right? So we had something called cassette piece or cassette tapes in our actually in our childhood. It's cassette tapes. So TT, this is actually cassette tapes. We had this in childhood, right? So I think I didn't thought that we have to show this as an image and all, but we had this kind of device. Anyone who has seen or not seen?
Seen, sir.
Seen, but not actually used, no?
I have seen, sir.
Right, okay. So this kind of tape we use in the earlier ages in our childhood. So if you want to listen a song, in the beginning, you have to go to the beginning. And if you want to listen a song in the middle, you have to forward this to the middle and listen that. If you want to actually listen to a music in the end, what you have to do is you have to fast forward to the end. And that is not random access. This is called sequential access. Okay, for an example, if you are in Gaul, if you want to visit Kandy, then Anuradhapura, and then Jaffna, you have to go in a sequential order. Sequential order. If you are actually going by a car, if there's a trip and you are going by a car, then you have to first go to Kandy. Sorry, first go to, maybe if you're using highway, you can go to Kadavatha, then to Kandy. Oh, then visit Anuradhapura and then to Jaffna. That is called sequential access. Instantly, you can't go from one location to another location like who? Like a time traveler. It is not possible to move from one place to another place instantly. Not possible. But think about a radio channel or TV channel. So if you start broadcasting in Gaul, same time, it will go to Jaffna, Kandy, Mahapale, Colombo, everywhere simultaneously. And the time taken to go from one location to another location will be almost same. So that kind of, right? That kind of behavior is called random access. That means you can access any location in this memory almost in an equal time. Random access means it is possible to access any location of the memory, any location in the memory in equal time. That is called random access. No need to move one by one. But cassette tapes, so this is called sequential. So actually, you should know example for sequential. Cassette tapes were sequential. You have to go one by one. And so not only that, it stores this random access memory, it stores currently running data and currently running application and related data stored in the RAM. Actually, this RAM is called dynamic RAM. dynamic RAM. Okay, let's write the note in a like single place, otherwise yeah, you will confuse with the note. Okay, the first thing that you should know, so let's separate the English note. Right, this is called a dynamic RAM. Dynamic RAM means RAM is why dynamic? It need periodically refreshing. So memory depends on the electronics. So sorry, memory depend on the voltage or the current. So that is called volatile as well. So it is also need to refresh this periodically to store the or keep the content. Therefore, it is called dynamic RAM. So these points you should know about the general random access memory. So please write the heading random access memory and highlight or write these points, very important, because initial lesson I have not given this all this content. Right. So do you have any doubt, any issue, then any unclear points? Sequential access and random access, is it clear? Sequential access, random access, is it clear? Come on, guys, you have to tell me, otherwise I don't know whether you understood or not, right? ඔගොල්ලෝ කිව්වේ නැත්තම් මම දන්නේ නැහැ පුතේ ඔයගොල්ලන්ට තේරෙනවද නැද්ද කියලා, right? Vanshika, please check again. So this some parts were not there in the note, right? So I know you wrote the lesson topic. I know you wrote the lesson topic, but some parts were not there in the note. That's why I'm asking you to add to that note. So especially this random access story is not there. This dynamic RAM thing is not there. Why it is called dynamic RAM? Because I have just added this content for today's lesson. Earlier, I have edited the same note, the lesson number 1, but I have added the extra content for today's lesson. So that's why I asked it, right? Okay. So anything unclear? Here and other at the random access, sequential access. Clear or not clear? Anuja, is it clear or not clear? Uttare den nona pute. Naththam mama danne naha.
Yes, sir.
Okay, then can you tell me this one? Dynamic, what is dynamic behavior? Dynamic means need periodically refreshment. Periodically refreshing is needed. That is called dynamic. Okay, so for an example, right. Have you seen hologram displays? Have you seen hologram fans or hologram displays? Anyone? Mama කොහොමද ඔයගොල්ලන්ව කතා කරවන්නේ? මට ඒක ලොකු ප්‍රශ්නයක් ඇත්තටම. ඔයගොල්ලෝ කතා කරේ නැත්තම් දරුවනේ මම කොහොමද තේරුම් ගන්න ඔයාලට ඇහෙනවද නැද්ද තේරෙනවද නැද්ද කියන එක මට හොයාගන්න බැරි වෙනවා. ඔයගොල්ලෝ ඒ කියන්නේ නැති දෙයට නැහැ කියන්න බය වෙන්නත් එපා. බැරි දෙයට බෑ කියන්න බය වෙන්නත් එපා. කවුරුත් ඔයාලව ගිලින්නේ නැහැ. නැති දෙයට නැහැ කියන්න. දන්නේ නැති දේ දන්නේ නැහැ කියන්න. බැරි දේ බෑ කියන්න. තේරුනේ නැති දේ තේරුනේ නැහැ කියන්න. So those are simple principles. So simple principles, then we can. So if we cannot interact, so my suggestion is, please let me do this as a video class. Then I can record the video prior to the class and send to you. Then you can watch this. If we can interact, we can continue as online class. So there are fundamental differences, right? Video class, you have one side. You can watch. That's the only thing. But take the advantage of online class. That real time, you can ask questions from the teacher. Use that option. මම ආපහු කියලා දෙන්නද දැන් මේක තේරුනේ නැත්තම්? Shall I teach again?
Understood, sir.
Okay, understood. Good. Right. Dynamic and static. Dynamic and static, actually, I can explain that using hologram display. So if you have not seen the hologram display, this is hologram fan. Hologram fan, you can just search this hologram fan display. This is a fan. Okay, this is a fan. Initially, this is a fan, nothing else. So, but let's go to the videos. You keep it in your hand. You keep this fan in your hand. Right, see how it's working. Okay, this person, you can see his, and this is the fan. This is the hologram fan. You cannot see anything 3D here, but this fan can be rotated. Rotating is something like dynamic refreshing. When you rotate the fan here in a faster manner, let me show something. It is possible to store data in this fan, and it is possible to send a video to this fan. Any kind of video you can send in MP4 format, or there are some other supportive formats. When you ask it asks it to play, so what will happen? Here you can see it will start rotating. It will start rotating. Okay, here. When it starts rotating, you can see objects in the space. But what actually happens is the fan is rotating. So since fan is rotating, you can see text in the space. So this is somewhat called periodically refreshing, because nothing is there, but due to this frequency or due to this periodical refreshment, you can keep something in the memory. So here in the space, nothing is there, but you can see a car. The car is there because of the periodical refreshing. So similar to that, monitor is also working like that. Monitor can periodically refresh. So by using that only, it keeps the lights illuminated. Okay, you can test this if you learn Arduino in grade 9. How many of you have learned Arduino in grade 9? Now tell me, how many of you have learned Arduino in grade 9? No one. Wow. If you have not learned IoT, Arduino, I invite you to come to grade 9 classes and learn that also, because that is very important. Okay, what you can try is this. So you can turn on a bulb. So let's say there are 2 LED bulbs. This is bulb 1 and this is bulb 2. Let's say you have 2 LED bulbs, bulb 1 and bulb 2. If you turn on bulb for 1 second and turn off this 1 second, and this is 1 second on, then this is 1 second off. So if you repeat this, the second time, this is 1 second off, and this is 1 second on. On for 1 second and off for 1 second. So the first second, පළවෙනි තප්පරේදී මේ bulb එක on වෙලා මේ bulb එක off. දෙවනි තප්පරේදී මේ bulb එක off වෙලා මේ bulb එක on. So what can you see? Is what can you see as the output? Yes, Janiru? What can
object like pictures?
No, I'm asking, I'm having 2 LED bulbs. That's all. පළවෙනි bulb එක on වෙනවා තප්පරයක්. ඊට පස්සේ තප්පරයක් off වෙනවා. දෙවනි bulb එක ඊට පස්සේ දෙවනි bulb එක පළවෙනි bulb එක on වෙනකොට දෙවනි bulb එක off වෙනවා. මේක off වෙද්දි මේක on වෙනවා. දැන් ඔයාලට මොන වගේ දෙයක්ද පේන්නේ in the string? Yes?
Light දෙක පත් වෙනවා.
Oh, light දෙක මාරුවෙන් මාරුවට පත් වෙනවා එච්චරයි. Nothing else. Okay, let me show this in our circuit construction kit. Actually, it's so if you have your support, I can do the class more interactively, right? But මීට වැඩිය තව ගොඩාක් දේවල් ඔයාලට කියලා දෙන්නත් පුළුවන්. ඔයගොල්ලෝ කතා කරනවා නම් අන්න එහෙම. දැන් ඔය කතා කරා වගේ කතා කරන්න. වැරදින් හරි කතා කරන එක තමයි හොඳම දේ. I appreciate that. It's a really good thing. Others also, please try to talk like them. There are some students who are not even talking, not even try to talk. කතා කරනවා කියන්නේ වරද්දක් නෙවෙයි. හරිද? අපරාධයක් එහෙම නෙවෙයි. Okay, let's say I have two bulbs like this, and I have a switch which is connecting these bulbs. Now both bulbs are turning on and off. So if both bulbs are turning on and off like this, you can see bulbs are flashing. What happens if I increase the speed? Off on speed, if I increase, what happens? Likewise, like this, I'm going to increase the speed. Now you can see more, it's flashing more faster, flashing more faster. So what happens if I further increase this? So this is not the behavior actually that I mean. So mata onone make on the arak off. So likewise, I just wanted to try like this. So one is off and the second one is off. Sorry. So let's forget about this for the moment. Okay, so you know, basically, so if I increase the speed further, if I further increase the speed, what will happen? Yes, if I further increase the speed of this, for an example, 0.1 second or 0.01 second on and 0.01 second off. On the second, this bulb actually 0.01 second off, not 1 second, 0.0. තප්පරෙන් 100න් එකයි. එතන මේකත් එහෙමයි. 0.01 on මේක off වෙලා ඊළඟට 0.01. දැන් තප්පරෙන් 100න් පංගුවක් තමයි වේගෙන් මේක වෙන්නේ. ඒ කියන්නේ තප්පරයට මේක 100 පාරක් වෙනවා. Now what you can see? If I do this, that means if I do this faster, what you can see?
The bulbs will glow more faster than earlier.
Yeah, bulb will definitely glow more faster than the earlier. And can you see the off time?
No.
No. Instead of that, you can see both bulbs are simultaneously on. But is it actually true? It's not actually true. Right? It's not actually true. Two bulbs are simultaneously on means that is not happening. This is actually on. When this on, this is off. When this off, this is on. But this is happening too faster, where human eye cannot recognize the off and on difference. So in that case, when it turn on, the illumination or the drawing which is there in your brain will not erase. Even before erasing, it will draw the next frame. So the frame rate or the speed is too high. So you can see both bulbs are in the on status. You can try this as a practical. ගොඩාක් වේගෙන් වෙද්දි මොකද වෙන්නේ? බල්බ් එක මාරුවට on වෙනවා අපිට පේන්නේ නැති වෙනවා. I think you have seen this in fans. So when you have three, so basically when you have a fan, so this same example, when you have a fan, right? So when you have a fan, you can see initially before turn on, okay, before turn on, you can see the number of blades. Number of blades in the fan. It is 3 here. 1, 2, 3. You can see. You can see there are 3 blades. But what happens if it is rotating? Can you tell the number of blades here?
No.
You can see. You can see. So it's everywhere there are blades. දිගටම blades තියෙනවා වගේ තමයි මට පේන්නේ. It's not continuous. It's not true. So if you take a photo or if you stop this somewhere, here also this is too much speed. So that's why it cannot rotate. But if you stop this, at a certain point, you can see only 3 blades are there. But with the rotation, you can't see that. So dynamically refreshing is something like this. you do it very faster. For an example, you have a cap. So you have 3 friends. There are 3 friends and you are rotating the cap. If it is too fast, if you rotate these caps too fast, then you can see both or all of your friends wearing caps. But that is not true. Since the scenario or the scene is too fast, that's why you can see all are wearing caps. If you can see all are wearing caps. Right? So that is the thing. That is the fundamental principle of this refreshing. Anyway, so this dynamic RAM uses the refreshing method to keep its memory. It periodically refresh, and share its memory with the programs. So we can see all programs are running simultaneous, but it's not. Actually, it's not. All programs are not running simultaneous. So one will run and the next one will run, but all are running one after another. But due to the speed, due to this faster behavior, we can see all are running. Okay, what happens if you copy one file to pen drive and start copying another simultaneously? Will it be slowed down or same speed will be kept? Assume that you are copying one file from one movie from pen drive to your hard disk. At the same time, you are going to start another file, another copying process. Then what will happen to the previous copying process? Or assume that you are downloading a file and you have started downloading another file. Then what will happen to the previous downloading process? Yes?
It will slow down.
It will slow down. But both will happen, no? Both will download. But the previous one will slow down. That means what is happening? Those are sharing the time periods or sharing the bandwidth. So the new file, when you do, okay, for an example, let's say you got iStream. I try to explain this as a simple, using simple examples, right? You have iStream. The same time you got a pudding. Now you want to eat both, right? 1 spoon of ice cream, another spoon of ice cream, and then pudding. Ice cream, pudding, ice cream, and pudding. Then you will slow down, but at the same time you will eat both. But if you had ice cream first and then pudding, then you can first finish the ice cream faster and then finish the pudding next. But if you eat both, the throughput, finally, the same time, you have taken same time for ice cream and you have given same time for pudding. But a person who can see, observe, he can see you are doing both, you are eating both. But actually what is happening, it will take the same time. But the second method is called periodically refreshing. You eat ice cream, then what lapa? Is ice cream, then what lapa? It's like copy the first file, then copy the second file. Copy the first part of first file, part of second file, part of first file, part of second file. Likewise, periodically you refresh, interchange between those two files. So that is what happening in the dynamic RAM. Therefore, dynamic RAM is quite slower. So dynamic RAM is quite slower. So please finish writing this immediately. So if you have previously written note, update your note by adding the new content. So this is called dynamic RAM. This can be removed and this need to be periodically refreshed. Okay, quickly add the note. So the next section is ROM, read-only memory. In Sinhala, it's called Pathana Matra Matake. So that is a special memory chip used to store firmware. So this actually I have given settings and drivers. So please write in addition to that. In addition to those, it has a special program called BIOS, basic input and basic input output system. This part was not there in your note previously. When you change BIOS settings, it is not possible to save those settings to the ROM. So why? What is the reason? When you change the BIOS settings, it is not possible to save those settings to the ROM because ROM is read-only. Simple, because ROM is read-only. Therefore, ROM uses a special chip called complementary metal oxide semiconductor. Complementary metal oxide semiconductor, Cmos, to keep the user preferences and changed settings. User preferences and change settings. Cmos chip uses a small battery to supply. Cmos battery uses a small battery to supply voltage continuously. When this battery is damaged or dead, you will notice when this battery is damaged or dead, you will notice daytime errors or recurring daytime errors. In your computer. So this is very important. Please write down these points related to read-only memory. So I think this part was given earlier, but you can add this additional note because now we are in the hardware lesson. I'll explain that. Please write down this first. The highlighted area, please write down, then I'll explain the process. Okay, so what is this BIOS? How many of you have accessed BIOS? Vanshika, have you done? Anuja, have you accessed BIOS in your computer? How do BIOS access kala tiyena? Yes?
No, sir.
No. Some yes, Ruvin, yes, some yes, some no. Okay, let me show this what BIOS is basically. So when you turn on the computer from the beginning, let me restart the computer. Okay, let me restart the computer. And so this is my computer, right? This think this as a computer. This is a virtual computer actually, computer inside computer. So please not or please see this section. This section please see this section, the highlighted area. It's very important. You can also see this in your computer, but fast in a second it will disappear. In a second it will disappear, so you won't be able to notice that. But this very important instruction will be there when you turn on the computer. Let me turn on the computer. So write virtual machine, and I'm going to restart. Okay, now see here. Okay, press F2 to enter setup here. Press F2 to enter setup. That's very important. Let me restart again. See this, right? Press F2 to enter setup. So at that time, so this is very fast. At that time, you have to press F2. here, that time itself you have to press F2, and that will give you this setup. This is called BIOS. Actually, I have password protected that, so it's asking me the password. Oh, so what's wrong with this? 1, 2, 3. Okay. So let me give the correct password and enter to this. And this is what BIOS is. So next day you can try this, right? Next day you can definitely try this when you turn on the machine. Please note in the bottom, this section, you can see, please F2, press 10 to press escape to press del 2, or some key will be there. Press F2 to set up, F1 to set up. You can see the system time, system date, and all the devices. And then the advanced setup, you can see. The second one is the advanced setup. There you can see the processor specification, chipset specification, cache memory. In the security, you can enter a password. This is where I enter a password. I just enter 1, 2, 3 as the password, and 1, 2, 3. Okay. So by adding a password, you can protect the computer. And so remember that if you give a password here, if you forget that, you have to reset this hardware using hardware. You can't reset this using software. Software will make a reset karanna bෑ මේක අමතක වුණා. Hardware වලින් reset කරන්න. So that much of important this password is. So give a easy one. And then the boot order, how to turn on the computer, whether you need to turn on using CD-ROM, or whether you need to turn on using hard drive, or whether you need to turn on using the removable or pen drive, you can edit. Likewise, basic settings can be, basic input-output settings can be changed. After that, you can press F10. Mouse will not work here. Only keyboard will work. Mouse will not work. Then you can turn off the computer by pressing F10, and so that will save the settings and exit. That is what the BIOS is. I think now you understood what that setup. That is stored in the Cmos. Sorry, that is stored in the ROM. And so what this ROM look like, I'll quickly show and finish the lesson for today. ROM is not CD-ROM. ROM chip is a chip in the motherboard. This is the chip. This is chip in the motherboard. And Cmos is also a chip in the motherboard. And Cmos battery means small battery in the motherboard. So this battery is used to keep time running, time and settings running, because ROM cannot save settings. So there's another chip called Cmos. ROM make a save karanna bෑනේ, read only. So it's saved in the Cmos, and this battery is used to keep that running. So if you forget the password, you have to remove the battery and reset the settings. Okay, then with that, I'm going to stop for today. If you need anything additional, you can ask me, send me a WhatsApp message. I'll explain this. I did this little faster, but next day I'll do a